Good morning. I'm Sharon Thatcher. I'm editor of Rollforming Magazine. On behalf of the magazine, the Construction Rollforming Show, and Schmitt Media, I would like to welcome you to the 2019 Construction Rollforming Show. We are offering this educational programming and launching the Construction Rollforming Association as part of an effort to help grow a safe and profitable industry. I would like to introduce Ben Schmidt. He will be making a presentation on when to replace roll.
All right, well, good morning, guys. Like Sharon said, thank you for the introduction. My name is Ben Schmidt. I work for the Bradbury Company. Primarily, my responsibilities are to sell our metal building product line into North America. So for us, that's panel lines, purlin lines, decking lines, and trim equipment. Specifically, what we're going to talk about today is a question that we get asked quite often as we're working with potential customers, existing customers. It's always, when do I need to replace my ag panel tooling? And so just so we're all on the same page, I'm sure most of us here are roll forming ag panel, but we call ag panel a 36-inch coverage panel, 3/4 inch tall, 9-inch on center, usually processes a 40 and 7/8 strip width, 26 and 29 gauge material. And what we're going to talk about today is what items indicate to us as we look at our tool set and also at our panels that we need to start looking at if we have a tooling problem or not. So Kevin, if you can click the next button over. So we're going to do that a couple of different ways here. First of all, I was talking to Sharon earlier. This is going to last about 25-30 minutes. So we have a good time slot here to fill. And I am not beyond Bradbury, so if you guys have questions, you'll get a Bradbury hat at the end of this. So we're going to look at this a couple different ways. One, what does worn tooling look like, the actual tools themselves? Second thing is, what do my panels look like that are going to tell me, hey, I need to start looking at my tooling for potential problems? And then what can I do without replacing my tooling? What can I do right now this afternoon to get a better panel out there? And then lastly, my tooling's worn, now what do I do? So Kevin, if you click on over. So we have a couple, there's basically two different types of tooling wear that we call it out there. One type is a catastrophic event. So basically something bad happened, usually you can see it, hear it, feel it when that happens. Over here on this side, this is going to be when you run tools together, and you can see there's like a galling here. And so what happens there, an adjustment was made, toolings came together, they ran steel on steel, and immediately you know something's going on. Panels run through, that's going to pick up paint, it's going to cause hot marks, a damaged panel coming out the end. When that happens, you know, a lot of times, guys, are at that point, your tools are probably need to be replaced, but temporarily, we've seen guys go in there and grind them, sand them just to get by, to keep running. Over here on the left side, that we look at here, this is going to be when some equipment or when tools are double sheeted. And double sheeting is basically just what it sounds like. More than one piece of 29 gauge steel goes through your machine at the same time. So what happens is when your tools are designed for a maximum gauge or 26 gauge 020, you send 3 015 sheets through there. Now you got 45 thousandths of material trying to go through 20 thousandths gap, and worst case your machine actually stalls and it just sits there and spins on it. Best case it gets through the mill, but you end up with what you see here with some worn areas there. And that's going to immediately wipe out your forming radii on your rolls. Kevin, if I did that for you. Okay, now this is what we're really here to talk about, normal wear on your tools. And so normal wear is going to be over a process of time as you run 29 gauge panel, you're forming steel with steel, and there's going to be a gradual decline in the bending radii on your rolls. So here's a couple of different scenarios. Over here on the right side, which is what we see most often, and along here, that's your bend radius. That's where we're setting that bend in there. As you run steel, that forming radius will over time become lessened, and so it's going to become loose. And you can see it in the dies. If you get up there and look, we we at Bradbury, our technicians, when they come out, they're gonna take radius gauges to check and see if it's correct with what you need or not. Then over here on the left side, this is more indicative of a driveline problem, and so we call this chatter, and you can see there's kind of waves that goes through there, and so what you would get there, or it can be chain slap, but your bottom arbor on your roll former is fixed, and so that's what's powered, and then we power the top with usually with a spur gear, and so as it goes through, that's how we're going to power the turn both at the same time. If your gears become worn, or if your drive line becomes worn and you get slapped, as that sheet goes through, you'll see your rolls kind of do this as it hits, and then that will translate onto your dies. What you'll see in the panel when you have chatter is you look down your minor rib, and you're going to see swirl marks going down it, and that's what that is from. Once it gets onto your roll, then the only way to get it off is to recut or replace that roll. Okay, so most commonly the way that we diagnose if we have a tooling issue or not is what's coming out the end of that roll former. And so what we're going to look at here is, as you look at your panel that's coming out, you have reduced overall features, which we'll talk about that here in a minute. The second thing that is, if you're not able to shrink up your coverage, if your panel is tending to run wide consistently, what happens there is, as we come down on the rolls, metal gets forced up into those bends. Whenever that tooling gets worn up there, you're not able to set those bends as much, and so it gets softened, and that extra steel has to go somewhere, and that's what makes your panel run wide. Overlap, wavy edge control, panel flatness control, our bend radius, and then finally, if you're running a post-cut production line, or if you're running pre-cut sheets, taking them to a secondary process to cut them down, if your panel is not at spec, that cutoff die is not very forgiving, so you start to see some deformation when you make those cuts. Okay, so overall, overform passes and features. So what I want to talk about, wanted this slide up here specifically, before we get into some photos of some panels that are run with good and with worn and with new tooling, is wanted to show you guys, these are the overall features up here. And so what you have on here, the way that we are able to, for example, control to get a tight lap is we have very small bends in this overlap right here. And what that does is if you have any looseness in that steel, it's going to set it, and then it's going to take out a wave, or it's going to keep it from opening up. And that's consistent all the way across here with all these different measurements. And so when we talk about overall features, we are finished forming these passes with these overform passes. Okay, so overform pass is when you bend steel, if you want it to get to here, you have to bend it to here first to allow for the spring back, right? So that's your high wear areas. And on this set of tooling right here, these are all the overform passes. So we start overforming the minors in 6 and then all the way through 13. So there's different pieces of tooling or passes that are going to help us establish this consistent panel right here. Okay, so reduced panel features, rounded majors and minor ribs. This is probably one of the easiest ones to see on your panel. And as we talked here, on the right-hand side is a set of tooling that's been run versus a new set on the left-hand side. So as you get in here, your majors, instead of having this nice, crisp rail or tip of that major rib, it starts to round on you. And then also on the minor ribs, what they'll do is, worst case, they turn into half moons versus that nice trapezoidal rib. Again, all this is leading to a wider panel, because you're not a round bend does not use as much steel as you come up and as a crisp bend on there. The other time you'll see it when your customers comment to you could be when they're walking across the panel and they're like, man, this just doesn't feel strong underneath me. And so that's because your bends are not set as crisply. The more bends, tighter bends in a panel, the stronger the panel is. And then of course appearance-wise as well. Panel flatness control. So as our tooling starts to get worn, we need to come down tighter to get our 3/4 inch rib on there, and to try to shrink panel coverage up. As you come down tighter, you start to lose angles here, and when you lose angles, that's where your flatness comes into play. So the way that we are able to control these cells right here, to keep it flat like up here, is in our minor rib passes. If you lose that adjustability, then you're going to lose your flatness control on your panel. Overlap control with wavy edge versus a tight lap, loose lap. So most folks in this business, the lap is just about everything, right? If you don't have a good tight lap, it's the first thing you guys look at. Makes sense because you're gonna, because it's not a weather tight lap. So here you cannot see the lap on there. Then we go over here and you start to see where it's opening up, and then there's a slight wave in there. And so again, it's as our tools become worn, we want to. It becomes more and more challenging to get both this lap right here tight, but then also the underlap rib has to be consistent as well, because that's what you're trying to lap onto. Okay. All right. This is worn bend radii, and so we look here. This is designed, should be like this, same panel, only this one's probably run about 60 million lineal feet, right? So you can tell the amount of material here that goes into these bends, we're not able to set that angle, versus over here, you have that nice shelf, you're able to set that angle. So again, it comes down to both an aesthetics, but also a strength challenge on there. Okay. And then lastly, as we look at a panel, the post-cut quality on it, that cutoff die is not very forgiving, and it knows what it's cut to. And if what you're feeding that for it to cycle through doesn't match, then something's going to give, and what's going to give is our 29 gauge panel, not our D2 cutoff die set. This also applies if we're running pre-cut and then we're chopping down for like our 2-foot panels or what have you. You will still see some deformation on there in this area. All right, so what can you do without replacing your tooling? Well, machine guys always say, call your paint man, call your coil man. It's not our fault, right? So, and then of course your paint guys say, well, call your machine guy. Just kidding. So the first thing we want to do is calibrate the machine. When you calibrate a machine or gauge it, if you will, you're going to be setting your vertical clearances, your horizontal clearances, that's within your passes, and then you want to set your pass-to-pass settings, make sure you're in line throughout. Most ag panel sets of tooling are 14 passes or 15 or 16, and everything works together. We call it progressively forming. And by that, what we're talking about is we usually form from the middle out. And so each concurrent pass needs to be in line with each other. So we're going to talk a little bit about how you gauge a middle. All right, so vertical tooling clearance. It's the gap between the upper and lower rolls at the farthest points on the inboard and outboard sides of the tooling for each pass, and at points along the flattest sections of the rolls where you have upper and lower mating. The tooling gap should be initially calibrated for the maximum material thickness for which the tooling was designed. So what does that mean? All right, so we're talking about one, you want to find out what your maximum materials, your set's designed for. That's our starting point. Most of us in the 26 gauge roll is going to be 021. And so we find that, and then we want to get a feeler gauge. So we got an 021 feeler gauge. Go ahead, Kevin. And now we're gonna gap our mill. And so inboard side for machine guys means drive side, outboard means operator side. So we're gonna take our feeler gauge and we'll do it here on the drive side and on the operator side. And we're gonna come down on the pass setting until our 20 thousandths gauge just barely drags through. Do that on the operator or on the drive, we do it on the operator. What we just did when we did that, we made sure that our arbor, our top arbor, is parallel to our bottom that we're set. We're not cocked this way or this way. And so once you have that established, then you want to do that from pass 1 all the way through to pass 14. The next thing to do is to check our in-pass horizontals. So we're going to go through the same process, only we're going to do that on the sides of the tools. And that way we're checking this way as we go through to make sure that we are consistent. Again, the main thing we want to do is engineers design in a perfect world. So we're always parallel, we're always top and bottom, and we're just making sure our gaps are the same around each piece of tube. Okay, so now pass-to-pass alignment. We talked about this a little bit earlier, and why is it important? Again, this is the similar print that we showed earlier. I just want to reaffirm to you guys that each pass works with itself as you go down through the set of tooling. So how do you check that? So what we do is you want to get like a 4-foot straight edge and find a common place along here. And this one right here is from pass 3, 4, 5, 6. And you set it up against this common roll. And then you want to make sure that you don't have more than a 10,000ths gap between from pass 4 to 5, 5 to 6, 3 to 4. Now, 10,000ths can be a lot if you're looking at your minor rib passes. So minor ribs, we like to see that about half of that difference. And what we're doing by doing this, what we're making sure isn't happening, we're making sure our tooling is not, or our panel is not snaking through those rolls like this. Because whenever you do that, you'll go tight one side, loose one side, tight one side, loose one side, and ultimately it's nearly impossible to get a uniform bend when you do that. Okay, so now we know we have a panel that we don't like. We went through and we gauged our mill. We know we're lined up. We still don't like our panel, so now we know we need to do something with our tooling. Generally, you have 3 different options on tooling. You can do a retrace and recut, which would be the entire set. You can do a partial tooling replacement, or you can just replace the entire set of tooling. We're going to talk about each one of these and the benefits and disadvantages of going that route. Okay, recutting. So what is it? What do you do when you recut a set of tools? All the tools and spacers are removed from the machine, sent to the factory. They're going to be stripped. They'll be retraced, reprofiled, going to be re-chromed, inspected, and profile tested. And then, so what do we do at the factory? So if you have a piece of tooling that's about this big, we generally are going to reprofile it to like new bends in there. To do that, we're going to shrink that OD about 70 thousandths. And that's how much of worn tooling we're going to take off. And then what are the advantages of it? One, it costs less money. Compared to a new set of tooling, you're about 50% the investment. Also, it takes less time to get that done. We don't have to saw the tooling down. We don't have to heat treat it. That's already been done. We're just going to profile, chrome it, and test it. Disadvantages to recutting it. There is a bit of a risk there. You don't know for sure that those rolls are going to clean up. So we take 70 thousandths off. If the tooling is worn extremely, or if there happen to be some damages in it somewhere, then if 70 thousandths doesn't clean that up, we have to take more off. Then at that point, you want to replace that roll versus cutting it down. And so there is a potential cost variable there. The other potential cost variable is on your drive line. Most of us are going to power our top arbors from our lower with spur gears. Well, if you cut too much down, then your roll decreases. You're not able to engage that gear. And so you may potentially end up having to replace your top gears to get a bigger gear, so you have better engagement on there. The other challenge or risk is there's very limited design changes available. And by design changes, let's say your substrate changes, your market changes, all of a sudden you got to run a bunch of aluminum thing on there. That tooling's already been designed. We're just taking it back to its original design. You don't have the ability to modify it very much. And lastly, it's very difficult for the non-OEM to provide you a quote to recut your tooling. So you're effectively a bit tied to the supplier of your tooling. All right, partial tools. So you can do that screenshot we saw earlier. We have a fair bit of customers that say, hey, I just want to replace my minor ribs because I need my flatness back. I just want to replace my overform passes. And that is done, that's another option. And usually you're looking at about 25% of the cost of a new set, and your lead time is much less. We're making much less pieces of tooling on there, usually 4 to 6 weeks to get you helped out. Disadvantages is your profile will not be like new, because you're taking new tooling and intermixing it with existing tooling, and there's no way to guarantee that that is going to be a like new shape. Again, limited design changes available. As your market changes, we're just putting in there what was there originally, and it's very difficult for someone besides your factory supplier to pull that. Complete tools. And so this is probably a bit more common what we usually do, but in this case we're going to replace all your tooling and spacers on an ag panel set of tooling. There is a bow correction fixture at the end, and for us it's kind of like the old canoe effect whenever your panel wants to do this, and how we straighten that out. Generally we're going to replace those fixture rolls as well, because if your tooling's worn and your fixture rolls are worn as well. And it is tested at the factory. You come in and you know that your panel is good. And so the tooling variable is taken out of the equation. The advantages are it's guaranteed to be perfect. We're able to introduce design changes to help deal with as your market changed. A couple of examples of design changes. I'll get into that a little bit later. Your tooling you're running right now can be run while your new tooling is being manufactured. You get less downtime, and you're able to source tooling from company XYZ to go on Rollformer WZX. So there's some bit more flexibility as you go through that. Disadvantages: cost more, takes longer time, right? Okay, so a couple examples over the last 10 to 15 years, really, of where we've seen the ag panel market change or kind of shift a little bit. The first one is, as customers came to us and said, hey, what can I do to deal with a wavy edge on my overlap so I can process this steel and not have to send it back? We introduced a overlap bead fixture, and all that is just what it sounds like. There's a little bend, so this is a normal lap, and that has the bead fixture on it. And all we're doing is we're just putting a little bend on that overlap, and that's going to take out that edge, that wavy edge. So that's one thing that we have to design the whole tool set around. The other item is when felt underlayment became popular, or started to get popular 10 to 12, 14 years ago. We had customers came to us and they said, hey, we're running this stuff on the bottom of our sheet and it's smiling at me. You know what? I want to run a flat sheet. And so we looked at that and we developed a tool set that can run with and without underlayment and have a flat per-spec panel. That's over here where you have this one panel has underlayment, the other panel does not. And one more click. So this is a short video here of a machine running, and what I want you guys to look at is later we'll pull up a panel and see one has underlayment, one does not. Just an example of what we can do when we design specifically for different substrates. So right there, it's going to lift it up. That has the felt on it, the other one does not. And unless you have tooling that's designed to accommodate that, then you're not able, then you're not going to get it as flat. Okay. Now we got tooling ordered. We know our machine's in line, but the big thing we wanted to stress to you guys is don't forget about your mill. The worst thing you can do is put a brand new set of tooling on a mill that needs help, and then you're going to get about a third of the lifetime out of your tools that you did originally. So, as a general rule of thumb, if your tooling's worn out, your your stands are probably worn out too, and you take a look at those. So most commonly when we recommend a Rollformer rebuild setup, we're going to address the stand bearings, the adjustment assemblies, and the drive line. And so on the stand bearings, what you have is you have this theoretical perfect area where all your rolls mount. If you get bearing wear, then you're going to start to side shift back and forth. And now what you're doing is you're not maintaining your gap where the steel goes through. And so your worst case, it's shifting so much that your tools might kind of kick each other or hit each other. What's most common is that gap gets real tight, and then so you're pinching that material, and then that creates quicker wear on your dies. Adjustment assemblies. So it's just what they talk about. The lower arbor is fixed, the top arbor raises and lowers, and usually it's with some type of all thread. And if those adjustment assemblies are seized up, if they're rusted and you can't get movement up and down, then you don't have your adjustability that you need to maintain your quality panel. The drive line, so inspect your sprockets, chains, spur gears, and drive rolls. And again, what we're looking for there is make sure we don't have chain stretch where it's gonna move violently or jerky, because that will ultimately transition onto your set of tooling. We have on where the tooling mounts on the arbor, there's a keyway that gets cut in there, and if that keyway starts to get wallered out, then you're going to have a similar case where your panels, where your dies can move without the rest of the shaft moving, and so you end up getting that jerking motion on there. And generally, your component cost to rebuild your stands is about 20% of the investment of a new set of tooling. That's what I got, guys. Love to take some questions, and if you ask a question, you get a Bradbury hat. So thanks again for your time. I sure do appreciate it. And if you guys have any questions, I'm here all day.
Did you find that your entry tooling wears faster than your exit tooling?
We find that our tooling that is doing the minor ribs wears first, and overforming, like doing our coverage sections in our lap. So that's typically what we see on that side. So not necessarily at the entry. So minor ribs for us, we're going to do passes 6 and 7. That's the first time we hit them. That's when we do the center ones, and then 10 and 11 is when we do the outer sections. So it's more of the feature that we're putting into it.
Yeah, we found too on a number 2 metal that it'll give some symptoms of more tooling with the wavy edge, deflection in paint, stuff like that. So, and run your next pass through and not do it. So
really?
number 2 metal.
Gotcha. Sure.
It can throw some false symptoms.
Yeah, for sure.
You mentioned, let's say you have worn tooling and kind of as a Band-Aid solution, branded and sanded and so on. Supposing you need to do that short term, what kind of sandpaper would you use in finishing?
That's a great question. I don't know is the answer. I mean, we see guys use Scotch-Brite, we see guys use just anything just to knock that burn in. You guys would probably know better than I would. You tried different things.
Well,
in the past.
I ran into that a month ago.
Okay.
And I went to an auto body shop and he said, well, it's got 600 grit. I wasn't sure if that's too coarse yet or.
Yeah, well, tooling, machine guys always get a little nauseous when you start talking about, sanding stuff down, but it's whatever it takes to get you by. But I sure can, if you give me, I can find out and shoot you a note later on before you go, grab your information, find out for you. Yes, sir.
Your solid roll tooling versus the other ones with the collars on it. What is the advantage or disadvantage?
Sure, very good question. So for those of you that aren't familiar with this, so solid tooling would be where you don't have an individual arbor that you slide your rolls onto. And so you're making your tool set segmented is a combination of spacers and rolls. Solid is we start with a large shaft and we profile the shape into it. From an advantages standpoint, you are in more contact with the metal on a solid piece of tooling. The reason for that is there's no spacers, right? So you're profiling it in and you're holding that consistent. A disadvantage to solid tooling is let's say you have a roll an area of a roll that gets damaged. Well, there's not a way just to replace a single roll. You're going to replace that entire top piece. So your investment, the cost of that is a bit more. Another disadvantage would be if you want to try to drop a shim in between to make a temporary correction on a solid piece of tooling. You don't have that ability because it's all one shaft. We design both sets quite often. On on one of our product lines, which is a company called Hayes International, they got in New Zealand, they use solid tooling almost 95% of the time for all types of shapes, from ag panel to R panel, U panel, all the way through. They have great success with it. Makes a good product on that side. On the Bradbury side, we've used it for a lot of decking lines. Traditionally, we tend to do more on the segmented side. So it's kind of a dealer's choice type of scenario. We both seem to work pretty well.
I have Hayes machines.
Okay, gotcha. How's it been for you? I mean, have you had any issues where you had parts of the roll that gets damaged, or?
I've only run it for about a year now, but I haven't had any problems.
Okay.
Sure. Minor adjustments, on the,
Yeah. My personal opinion is, with the solid tooling, you're able to have a lot more metal engagement without having just a whole ton of extra tooling in there. So I think you hold that panel better on solid.
Say minor ribs need replaced, fix that part of it, how much longer before the rest of it goes, I guess?
It's good, it's a really good question. So a rule of thumb on segmented tooling is most guys will see, a lot of folks will see minor rib wear at probably about half, at a third of a tool's life into it versus the whole set. So, but the reality is most of our customers that most experience I've had with guys is they don't just replace the minor rib passes. They just let it run, and then, when the whole thing's ready to be recut and replaced, they take it off and put it there. But it's, I would say, at about 20 million feet on a typical on a typical through hardened tool set, about 20 million is where you're going to see minor ribs start to show a little deformation. And again, the challenge is that none of this happens overnight. And so as you run, it's difficult to see. I mean, it's kind of like on my house, I know my paint's fading, slowly, but you don't know, it doesn't just happen overnight. And so it's kind of a gradual decline, if you will. And where it becomes real important is if you have multiple facilities or multiple lines shipping to the same customer trying to have uniformity is, that's where a lot of our customers will change tooling more often than someone that has a line, because you don't have to worry about a line from Michigan, shipping the same customer to a line in Ohio. So but I would say about a third of its way in, if you're gonna be really conscious of it, that's when you would see it.
What about options for different tool seals?
Yeah,
different options?
great question. Yeah, absolutely. So we generally, on ag panel tool sets, our initial tool steel offering is a 4150 anneal tool steel. That we will. So what we do is we cut it the first time, and then we heat treat it, and we're gonna heat treat. We're gonna draw that back to about a 56 to 60 Rockwell rating, and then we take it and then we reprofile it again. So that's our base offering. As we've learned about tool steel, and as steel's gotten harder, we get a lot of guys now that we provide an option to go to a D2, which is the next step up from a wearability standpoint. In our experience, you get about a 25% more lifespan when you go to D2. What's very common is to do kind of a Heinz 57 of tool sets, where your main set will be 4150 anneal. And then on your high wear areas, so your minor rib passes, your overform passes, make those out of D2 to try to get it to kind of wear together a little bit better. We also do some at a DC53, which would be the next step up from a wearability function from D2. And that usually, I'd say probably another 10% more life over and above D2. Those are the